What's up, y'all? This is Tom, and this is Like a Math Class. In this video, we're going to continue our discussion of calculus, and we're going to look at the quotient rule. The quotient rule is when you've got a rational function that you're trying to derive. So that means you've got a function in the numerator and a function in the denominator. And it's not easy to simplify them into like a sum and difference rule, kind of going back to our basic rules of derivatives. So you're just going to want to take that numerator and take that denominator, and you want to find a way to do the derivative of this whole chunk. And that's what we're going to do in this video. Let's get to it. The quotient rule says if you've got some function and it is equal to a rational function, which means you've got a function in the numerator and a function in the denominator, then the derivative of that is this giant mess. And this mess says that we've got the original function for your denominator times the derivative of your numerator minus your numerator times the derivative of the denominator. And so and then all that is divided by the denominator squared. Keep in mind, this is in your formula book for the IB course, so you don't need to memorize this. I wouldn't even recommend trying to memorize this, because most likely you're going to get these U's and V's and DV's and DU's a little bit mixed up. It's not as critical in the product rule, because in the product rule, you can have those two things switch and it doesn't matter because you're adding the two chunks together. But in this, with the the order of it in addition, it doesn't matter. The order of subtraction definitely matters, so you don't want to mess this up. Use the formula book. Don't rely on your memory with this. Key tip: use the formula book. I'm going to map this out again, and again, we looked at in the product rule video, we looked at, hey, if we want to call u of x, and maybe we've got another thing that we call v of x, our numerator and our denominator here. Ultimately, what we're going to want to do is we're going to want to find the derivative of u of x, and we're going to want to find the derivative of v of x, and then just drop these pieces into this whole formula. So color coding, like I like to do, our u of x is our original, and we can see that we have our original u of x right here after the subtraction sign. The derivative of u of x is here right before the subtraction sign. The original v of x is here in the first part, and down here squared. Please note that that thing is squared. And then down up here and here is our v prime, the derivative of v of x. All right, let's look at an example and see how this all works out. So here we've got two functions. We've got our u of x up here, our v of x down here. So I'm going to map it out just like we've done right here, just to kind of organize my thought. As you get more comfortable with this, you might be able to do it all on the fly. But as we're starting to learn how to do this, it might be it's definitely recommended to map out your different pieces and then just drop those in. A u of x will be 3x squared plus 5. The derivative of u of x, is 6x. Then we have v of x is equal to x cubed plus 4, and the derivative of v of x is 3x squared. All right, let's do this whole thing now. So our derivative, f prime of x, is going to equal the original v of x. So we've got x cubed plus 4. Then we have the derivative of u. The derivative of u is times 6x minus the original u, which is 3x squared plus 5, times the derivative of v, which is 3x squared. And all of that is over our original denominator squared. So our original denominator is v of x, so we'll have x cubed plus 4 squared. All right, now we have the fun of trying to simplify and see if there's anything that we can do with this to make it a little bit easier to work with. And I don't think there's going to be a whole lot in this particular example. So I'm going to distribute this 6x over these pieces. So I'm going to end up with 6x times 4, 6x times x cubed. So I'm going to have 6x to the 4th plus 24x minus, now it's minus this whole chunk, so we'll want to keep that so that way, because it's subtracting all of this. So after we distribute these things, we want to make sure we distribute the minus, the negative sign or the minus sign across that. So that's why I'm putting this into brackets. So we're going to take 3x squared, we're going to multiply it by 5 and by 3x squared. So we're going to have 9x to the 4th plus 15x squared. So all of that over x cubed plus 4 squared. Now, I typically do not expand the denominator because there might be some simplifying that you can do in the numerator, or it doesn't really help us with our calculations. Because again, if we're trying to find this for some value of x, if we're trying to find where the slope is at a specific point, we're going to want to drop those values in. So to calculate all of this will be much easier to just leave this in parenthesis form. F prime of x is 6x to the 4th plus 24x minus 9x to the 4th minus 15x squared, all over x cubed plus 4 squared. And finally, as we combine our like terms, we get a derivative of minus 3x to the 4th minus 15x squared plus 24x, all over x cubed plus 4 squared. And because I can see it, I'm just going to check it. What happens if I factor out? These are all divisible by 3. These all have x's in there. Let's just see what happens if we bring 3x out. Let's see if that makes a difference in our simplifying. I don't know if it will. I don't think it will, but let's give it a shot. I've got I'll pull out a minus 3x. So minus 3x, so that's going to leave me with x cubed plus 5x minus 8, and all of that over x cubed plus 4 squared. And I don't think that if we were to try to factor this, I don't think we would have the same, this is cubed down there. I don't think we would have, if we were trying to factor this, I don't think we would have anything that could simplify with this. So I'm just going to leave it at that, and that is our final answer for this derivative. Let's look at one more example, and then we'll call it a video. Call it a day, call it a video. All right, so we've got dy of dx. Find dy of dx for this function here. U of x is x minus 1 squared. U prime of x is equal to 2 times x minus 1 to the first power. This is a chain rule. Actually, we got a chain rule in the numerator and the denominator. So 2 comes out, 2 times x minus 1, subtract 1 from my numerator, times the derivative of the inside, which is just times 1. So my derivative here is 2x minus 2. V of x is x plus 2 squared. V prime of x is 2 times x plus 2 to the first power, and then the derivative of the inside is again just times 1, so I'm left with 2x plus 4. Oh, well, these two things are kind of similar. I wonder if that's going to work out the same way. So let's do our colors again. So what colors do we have? Yellow, green, purple, pink. So our derivative function, not f of x, our derivative function dy of dx is equal to, let's double check, purple, green, yellow, pink. Purple, green, yellow, pink. So it's almost like that. There we go. The original v of x, x plus 2 squared. Notice I didn't even look at the derivatives of these things. I just mapped them out by colors because that's how little I actually remember of this formula. And again, that doesn't say anything negative about me. It just says, I know I'm always going to have that formula book available. Why do I need to use my brain space to remember that? I don't. Let's do this. The derivative of u is 2x minus 2 minus x minus 1 squared, and then times 2x plus 4. All of that is over x plus 2 squared again. All right, dy, and now we're just going back to the grind of simplification. Gosh, I don't know. Oh, wait. Look at this. X plus 2 squared. This is going to be an x plus 2, right? If I take 2x plus 4, I can factor out a 2, and I'm left with x plus 2. So I've got something that I can simplify out of all of this and with my denominator. So let's do that. X plus 2 squared times 2x minus 2 minus, again, it's kind of a long drawn out process here, times 2 times x plus 2, and all of that is over x plus 2 now to the 4th power. Remember, a power of a power, we just add or multiply those exponents together, so we have the 4th power here. So if I've got two of these x plus 2 squareds, and I've got one x plus 2 over here, I could factor out one x plus 2 from all of this. All right, I'm going to take it in a step just so you can see it. dy of dx is equal to, I'm going to factor out that x plus 2. And then I'm going to put a giant brackets around this. And I've got one blue x plus 2 left. Because if I take this and I distribute it across here, that would make x plus 2 squared. The purple comes along for a ride. Minus this thing, x minus 1 squared times 2. Again, all of that is in the numerator. If I were to take this and multiply it in, there's my squared. If I take this and multiply it over here, I've got 2x or x plus 2. Remember, I don't do to each one of these things because this is multiplication. I only do it per term. This whole thing is actually one term. This whole thing is one term. So I just keep it as that. And then I've got x plus 2 to the 4th power. And now I can do, see you later. Make that to the 3. And I think that's actually the last spot that we can go. And let's just do our last bit of simplifying here.
We're going to have x plus 2, 2x minus 2, minus x squared, or x minus 1 squared times 2, all over x plus 2 to the 3rd power.
Is there any more to simplify? Even if I expanded this, right? This would be, it's going to be x minus 1 times x minus 1. I might be able to get an x minus 1 out over here, but it's not going to be able to simplify down there. So, like, again, maybe you could factor out an x minus 1, like first factor out a 2 here. So that would be 2 times x minus 1. That would be this piece right here. You might be able to do that, so then you factor out an x minus 1 all the way out. But honestly, I don't know if that really makes it that much more simple. I think what we've got here is probably the most simplified and the most straightforward way to go. So I would probably stop here. Again, it's entirely possible that we could expand these things out. We would have x squareds up in here. We would have some x squareds in here, and we can combine this into one long polynomial of the 2nd degree. I don't know. You could. You know what? I'm gonna pause this, and I'm gonna just do that for you so you can see what it is. I'm not gonna take you through that whole process, but I'll pause it. I'll bring it back, and then you can look at that, and we'll compare to see if these two things are any more equal to each other. The magic of editing. So hopefully you paused this and you walked through that process as well to see what we came up with when we simplified that whole numerator. And look what we actually got. I was wrong. that actually simplifies out much better. So it might be a good idea when you're stuck with something like this, seeing that we're going to have all x squareds in there. We're not going to have like an x to the fifth, to the fourth, to the third, to the second. You know, just by the way this worked out, I can see that my highest powers are going to be x squared. It actually is a good idea for me to go through this and simplify that numerator, because that is indeed much simpler than this. And if we were looking at an IB exam, if we left it like this, we would not probably get full marks. We would want to go here. Now, if you wanted to go here, or if you wanted to say 6 times x minus 1 over x plus 2 cubed, I don't think that's really going to matter one way or the other, but you definitely want to do a quick scan, a quick check. Is it going to make sense for me to try to simplify this, or is it not? That's it for this video. I'll talk to you in the next one.